Lake Tahoe sits on three massive fault lines that scientists warn could trigger a catastrophic tsunami. And right now, the lake is surging toward record levels that haven't been seen since 2019. But here's what the clickbait headlines won't tell you. There's zero scientific evidence that rising water levels are reactivating these faults. And the real story is far more fascinating than the fear-mongering suggests. Let me set the record straight about what's actually happening at one of America's most geologically volatile lakes. Lake Tahoe sits at 6,227 feet above sea level as of February 2025, just 2 feet below its maximum legal limit of 6,229 feet. That recent surge added a staggering 12 billion gallons of water in a single week, courtesy of the atmospheric rivers pummeling California's Sierra Nevada. To put that in perspective, it takes 16 billion gallons just to raise this massive lake by half a foot. We're talking about the second deepest lake in North America. 1,640 feet of crystal clear water sitting in a basin that literally owes its existence to earthquakes within the active Walker Lane seismic zone. But before we explore the real earthquake risks lurking beneath those pristine waters, let's address the elephant in the room. The sensational claim about fault reactivation triggered by water levels? Complete nonsense. I've combed through every scientific paper, every geological survey, every seismic monitoring report, and there's absolutely no evidence supporting this connection. The scientists studying Lake Tahoe's faults aren't losing sleep over water levels. They're worried about something far more inevitable and terrifying. Here's what actually keeps geologists awake at night. Lake Tahoe sits on three major active fault lines that are essentially geological time bombs. The West Tahoe Fault runs the entire length of the lake's western shore, stretching from Dollar Point all the way south. The State Line Fault cuts through the North Shore near Crystal Bay, and the Incline Village Fault runs right behind an elementary school, though it's the smallest and least active of the trio. Dr. Jean Ichinose from the Nevada Seismological Laboratory at the University of Nevada, Reno, puts the odds of a magnitude 7 earthquake striking under Lake Tahoe at 3 to 4% over the next 50 years. That might sound reassuring until you realize what happens when one of these sleeping giants finally wakes up. Graham Kent from Scripps Institution of Oceanography has spent years mapping these underwater fault systems using cutting-edge sonar technology and LiDAR mapping techniques. What his team discovered would make any coastal resident nervous. These previously unknown faults at the bottom of the lake are active and capable of producing large earthquakes, explains USGS geologist Jim Howell. The West Tahoe Fault is capable of a magnitude 7 earthquake, with the added danger of nearly 500 meters of overlying water, which is capable of spawning a large tsunami wave. Think about that for a moment. We're not talking about ocean tsunamis here. We're talking about massive waves generated in a mountain lake surrounded by million-dollar homes, marinas, and tourist infrastructure. The modeling is chilling. A magnitude 7 quake could cause sections of the lake bottom to drop like a trapdoor, plunging as much as 13 feet in seconds. The displaced water has nowhere to go but up and out, creating tsunami waves potentially reaching 30 feet high. This isn't just theoretical. It's happened before on a scale that defies imagination. Somewhere between 12,000 and 21,000 years ago, an earthquake triggered what scientists call the McKinney Bay landslide, the second largest landslide in North America. Picture this: 3.5 cubic miles of mountainside suddenly collapsed and slid 15 kilometers across the lake floor. When that massive wall of rock and debris hit the water at crushing speed, it displaced enough water to create waves 300 feet high. Essentially a liquid skyscraper of water that lowered the entire lake level by 30 feet. Dr. Richard Schweikert from the University of Nevada puts this in perspective. Lake Tahoe is the only lake we are aware of that has features like this, out of anywhere else in the world that has been documented. The evidence is still there on the lake bottom. House-sized boulders scattered across the floor like geological confetti, and massive chunks of mountainside larger than city blocks resting where they came to rest thousands of years ago. The water from that ancient mega tsunami didn't just disappear. It burst over the lake's outlet at Tahoe City and roared down the Truckee River with such violence that house-sized boulders were carried as far as the Nevada border. Boulders that still litter the riverbed today as monuments to that prehistoric catastrophe. Now I know what you're thinking. That was thousands of years ago. Surely we're safe now. But here's the unsettling truth. The West Tahoe Fault last ruptured its entire length 7,800 years ago. The most recent activity on this fault system was 4,500 years ago. The incline fault last moved about 575 years ago, around 1450 CE. Paleoseismology research at nearby Fallen Leaf Lake has revealed that in geological terms, these faults are locked and loaded. Gordon Seitz, a geologist at San Diego State University, explains the problem. These big faults are completely dormant between earthquakes. They can sit quietly for thousands of years, building up stress, until something finally gives way. It's like a massive geological spring being slowly wound tighter and tighter until it eventually snaps with devastating force. The current water levels everyone's getting excited about? They're actually not that remarkable in historical context. The lake naturally fluctuates within an 11-foot range. The record high was set back in July 1907 at 6,230-1.2.6. That's 2 feet higher than today's legal maximum. The record low came during the severe drought of November 1992, when the lake dropped to 6,220.2006 feet. Lake Tahoe has reached the maximum legal limit multiple times in recent years, 2017, 2018, and 2019, without triggering any seismic activity. Chad Blanchard, Lake Tahoe's watermaster, provides crucial context about these water level dynamics. Each year, approximately 40 inches of water evaporates from the surface. That's 55% of the lake's total outflow. The recent surge from atmospheric rivers is impressive, but not unprecedented. The lake added 12 billion gallons in a week, but it regularly loses similar amounts to evaporation during hot, dry periods. So if rising water levels aren't triggering earthquakes, what about the reverse connection? Could earthquake activity affect water levels? Here's where it gets interesting. There's a scientific phenomenon called reservoir-induced seismicity, but it typically applies to artificial reservoirs created by large dams, not natural lakes like Tahoe. The weight of water in artificial reservoirs can indeed trigger small earthquakes as it affects underground pressure systems, but this requires very specific geological conditions and usually involves much more dramatic water level changes than Tahoe experiences. And here's another key fact. Only about 0.63% of the world's largest dams over 10 meters high have ever induced seismicity. For reservoirs deeper than 140 meters, which would include Lake Tahoe's depth, about 21% have shown some induced seismic activity. But again, this research focuses on artificial reservoirs, not natural alpine lakes with their own established equilibrium. The real seismic action at Lake Tahoe happens on its own schedule. In July 2024, residents got a reminder of this when a swarm of nearly 40 small earthquakes centered in the middle of the lake started rumbling around 7 a.m. on a Saturday morning. The two largest registered 2.3, 4, and 1.9 on the Richter scale. Barely noticeable to most people, but significant enough to catch the attention of seismologists. Ken Smith from the Nevada Seismological Laboratory explains that South Lake Tahoe actually experiences about 2,200 earthquakes per year on average, though most are too small to feel. The region typically sees 1 magnitude 4 or higher earthquake every year, 1 magnitude 5 or higher every 7.8 years, and 1 magnitude 6 or higher every 25 years. It's the big one, the magnitude 7, that everyone's watching for. When that inevitable major earthquake does strike, the consequences extend far beyond just the immediate shaking. University of Nevada researchers have run computer models showing how a magnitude 7 earthquake could create what they call Seiche waves, massive oscillations that would slosh back and forth across the lake for hours. Jean Ichinose describes it perfectly. Think of the lake like a pan full of water. When you knock one end way down, the water surges and then sloshes back and forth for some time. These aren't just theoretical concerns. The geological record shows that the Tahoe Basin has been shaped by these violent events throughout its history. The lake itself exists because of seismic activity within the broader basin and range province. It formed over 10 million years as powerful mountain-building processes, uplifted the Sierra Nevada range. The basin took its current shape when seismic thrusting triggered a dramatic land collapse on the eastern Nevada side. Lava from Mount Pluto eventually sealed off the northern end, and the deep crevasse filled with water to become Lake Tahoe. Steve Boland from the California Geological Survey puts it succinctly: the lake owes its existence to faults. This isn't a case of a peaceful mountain lake that happens to have some earthquake risk. This is a body of water that exists precisely because of massive geological violence. So what does this mean for the millions of people who visit Lake Tahoe each year and the thousands who call it home? Graham Kent, who has spent his career studying these risks, offers some perspective. I work with fire departments. I'm worrying about Tahoe burning down about 10 to 20 times before we have an earthquake. He's referring to the very real and immediate threat of wildfire, which poses a much higher statistical risk than seismic activity. But that doesn't mean the earthquake risk should be ignored. Jim Howell from the USGS puts it bluntly: it's a wake-up call. This is a good time to think about earthquake preparedness. In fact, Lake Tahoe is due for a major earthquake will strike the Tahoe Basin. It's when. The geological evidence shows these fault systems are capable of producing the kind of massive ruptures that reshape landscapes and create the kind of tsunami that could fundamentally alter one of America's most beloved mountain destinations. Recent research has revealed just how interconnected these fault systems might be. Scientists suspect all three major faults, West Tahoe, State Line, and Incline Village, could be linked deep underground. If that's true, a major rupture on one could potentially trigger activity on the others, creating a cascading seismic event that would make the individual fault risks pale in comparison. The water clarity data from 2024 adds another layer to this story. Researchers at UC Davis found that Lake Tahoe's famous crystal clear water has been getting murkier, with visibility dropping to 62.3 feet, the worst since 2021 when wildfire smoke and ash clouded the lake. The sediment-laden runoff from heavy precipitation years like 2017 and 2024 shows how dramatically the lake responds to environmental changes. This brings us back to those recent water level surges. While they're not triggering earthquakes, they do represent the immense power of the atmospheric rivers hitting California's mountains. When a single week can add 12 billion gallons to a lake this size, it demonstrates the massive scale of natural forces at work in the Sierra Nevada. The real story of Lake Tahoe isn't about water levels reactivating faults. It's about living in one of the most geologically active regions in North America, where the beauty of alpine lakes and towering mountains comes with the inherent risk of the powerful forces that created them. Those three fault lines beneath the crystal clear water aren't going anywhere, and eventually, one of them will remind us why this basin exists in the first place. For now, Lake Tahoe continues its natural cycle of filling and emptying, rising and falling within its historical range, while the sleeping giants beneath remain dormant. But the geological clock is ticking, and when it finally strikes, the resulting tsunami won't need any help from rising water levels to reshape everything we think we know about mountain lake safety. The next time you see headlines about Lake Tahoe's water levels triggering geological catastrophe, remember the real science. The catastrophe potential was built into this system millions of years ago, and it's been patiently waiting for its next moment to reshape the landscape ever since.